Witsit, do you want to have a go with Dr. Parks for a little bit?
No, I don't care. I just
Birthday
think
gift.
it's funny
I
that
was just curious about Brian, I have never done this. I've never done figuring out magnetic declinations, but I will say that if someone had told me, can you find true north or true south as an astronomer, I would use the stars because right ascension declination, that is a fixed system, and that will give me where true north and true south is.
I thought that's what Brian's point was.
I don't know. Maybe it is. I don't.
That's what I was getting. I thought he was basically saying, look, if you can't trust your map, you can't trust your compass, then what do you got to... everybody's going to be looking to celestial bodies, right? You're going to be looking up.
Hey, Professor Parks, do you agree that relativity's already been disproven?
I do not.
Really? So, like, just being off by 96%, it's still a viable theory?
So you realize you're going to have to give me more context.
Relativity's predictions are grossly off on the cosmological scale. It's not even remotely close to viable.
Can you be more specific?
Sure. As early as 1933, we discovered, looking at the galaxy clusters, that it only had 1% of the predicted mass. You have the accelerative expansion rate problem. You have the galaxy rotational problem. You have overall distribution of the galaxy problem. Relativity's predictions do not match what we see at all. It doesn't even account for 96% of what is there. In order to save relativity, we have to make up to unidentified, undefined phenomena as a placeholder to keep it alive.
So you're talking about, I think you're talking about dark energy and dark matter.
Yeah.
Dark energy actually was predicted. Well, the cosmological constant was actually predicted by Einstein in the early 1900s, but he claimed it was his greatest blunder when Hubble discovered that the universe was expanding because he no longer thought it was necessary. It was only recently when we realized that the expanding universe was accelerating, that the cosmological constant was really brought back in and is being used to characterize dark energy.
About how fast it's expanding.
Yeah, and dark matter is not directly related to relativity per se.
No, but dark matter is a made-up concept.
Dark matter is, so we see, if we look at, say, a spiral galaxy and we look at the rotation rate of that galaxy, that rotation rate is not Keplerian. And so it has a flat rotation curve. The only way that can happen is if the mass is uniformly distributed throughout the galaxy. From direct visual observations, well, really direct any kind of observations using light, we don't see a uniform distribution of matter throughout that. So dark matter has been invoked to explain that.
You mean to save the theory that's provably wrong?
Well, I wouldn't. I would disagree with your notion that is proved wrong. It is.
And how do you prove something wrong then? If I have a theory and it predicts 100 pennies, then I go and there's only one penny. If I make up an idea of 99 invisible pennies that are actually there, but I don't know what they are, they're not like any other pennies. I can't find them. I can't define them. I can't actually prove to you that they exist. But we're going to pretend there are 99 more pennies there so that my theory of the 100 predicted pennies is correct still. How can you prove a theory wrong then? If you can just make up names to fix the gap.
So the scientific method works with, you come up with a hypothesis, you test it, you see what happens. Now, and you continue to do that but occasionally you will, as you rightly point out with dark energy, this is not something that was predicted without bringing back in the concept of the cosmological constant. And so you have two options in this case. You can either throw out the entirety of relativity, or you can attempt to augment relativity, which is what we're trying to do now.
So it's pseudoscience. It's actually, by definition, a
No,
religion.
that is not suicide. That is how science is actually done.
No, it's
I'll
not.
give you
In
another
science,
example.
you have a hypothesis and a null hypothesis. And so when your theory predicts something, you're like, okay, this is what my theory predicts. This amount of mass, this amount of gravitational effect. This mass displaces space-time and bends and warps it this way and has this gravitational effect. That's your theory. That's your hypothesis. Then you see set amount of mass, and then you see way more gravitational effect than your prediction of your theory of gravity. Then it's the null hypothesis. In science, that debunks the theory.
So
This is not science, this is a religion. So relativity, no one's come up with a better answer than relativity. So we're just going to keep it until we think someone come up with something better, even though it's been proven wrong, to such an extent that for almost a century, we've kept a 99% placeholder that can't even be defined.
okay, so again, dark matter has nothing to do with relativity. What dark matter is that from a dynamical standpoint, and actually, in actual fact, relativity is never really used to determine dynamical mass. Actually, mechanics is used to determine the dynamical mass of galaxy because the mass is or the rotation rate is so slow, but it makes the math easier. I can give you an example of how science, works. Is we have the Nice model of came into being prior to the mid 90s. It was a nebular theory where basically a cloud of gas comes down due to gravity, causes a protostar, creates a circumstellar disk. From the circumstellar disk, you have the coalescing of planets. And so from that simple model, we believed that terrestrial planets could only be in the interior part of the solar system, and Jovian planets could only be in the outer parts of the solar system. But then we found hot Jupiters. And so what we had to do was we could take that nebular theory and just toss it out the window, or we can say that we don't have a complete understanding, and we realize that planetary migration is a thing, that you can actually have gravitational interactions between the planets, the protoplanets in the disk, protoplanets with themselves, and so forth. So that is what's happening with relativity, is that we're at a stage now that they are attempting to make, because relativity gets so much of other things right, they are in a process now of trying to modify relativity in order to account for these or basically these things that relativity cannot previously account for.
You mean in majority? So like it's a talking point that everyone repeats ad nauseam because it's a cult. So everyone repeats the same talking points. Relativity is the most tested theory ever. Relativity gets so much more other stuff correct. It's just a talking point. It's all fluff. In reality, right? We didn't recently discover anything. It's been a century within 15, 20 years of it being proposed. So within 15 years of it being proposed, it was debunked. Now we're almost 100 years after that, and it's still here with undefined mathematical placeholder on it as if it's correct. And it gets even worse for relativity on the quantum scale. It can't be applied anywhere. General relativity can't even step the foot in the door of quantum mechanics, has been thoroughly refuted. So it doesn't work on the small scale or the big scale. But hey, it can explain downward acceleration, which can be explained with about 1,000 different theories. So it must still be true. It must still be true because of stuff like Michelson-Morley. Michelson-Morley is the only reason that relativity is held on to, because no one has proposed a replacement for gravity that could explain Michelson-Morley. It's the only way is that there's length contraction and time dilation. That's why it still sticks around to this day.
No. So,
well, how do you falsify relativity?
We don't stick to relativity because of Michelson-Morley. We stick to it because of gravitational lensing. We stick to it because of muon decay. We stick to it because of observed time dilation and GPS satellites.
That didn't work. Relativity didn't work.
Again,
Relativity didn't work for that. We had to bring in Ron Hatch, who had to specifically use a Lorentzian etheric model to help fix the relativistic discrepancies of time delay within satellites and GPS.
And again, to say that I'm a cult member is a bit insulting.
Well, I didn't specifically call you a cult member, but you are propagating a cult-like belief. Because when I asked you, how do you claimed science, but you're actually purporting the opposite of science to be science. Like I asked, how do we debunk relativity? No one will even utter an answer because that's like blasphemous. No, you don't refute relativity. That's the linchpin of the belief. That's not even, how dare you? How dare you say anything about I asked, how do you debunk it? Do you in science, if a theory makes a prediction and then the evidence directly goes against the prediction, is the theory right?
The theory either is completely wrong or needs to be adjusted.
So you could say that about literally everything. So then it would be impossible to ever debunk any theory.
That is essentially how science works, is that it is
No theory's ever been debunked and everything's still on the table.
Well, no, I wouldn't say that every theory has been debunked, because let's look at the difference between classical mechanics and relativity. There were a number of cracks in classical mechanics before relativity was proposed, and it got to a point where, Einstein came up with relativity, and what relativity could do was that it could basically explain everything that classical mechanics could do, and could explain these new cracks that were coming into being.
Cracks
So-
like what? Let's get specific. Let's name
Like
it.
Mercury?
Because he didn't come up with anything. Einstein didn't come up with anything. He didn't even come up with the curvature of space and time. That was Henry Poincaré. He literally came up with nothing. All he did was put it together and have his wife do the math that he couldn't do. So Einstein didn't come up with anything. So what were these cracks in classical mechanics that Einstein stumbled around half naked, thinking he's a woman some days, when he became a genius? Well, what cracks did he fix?
I have no idea where the thinking he was a woman has anything.
Well, he cross-dressed, and he wrote about how sometimes he was confused as to his very person, and he was a mentally deranged, insane person.
How does this have anything to do with this discussion?
Well, because he's being propped up as some type of genius that invented something. He didn't come up with anything. He didn't come up with the bending and warping of space-time. That was Henry Poincaré. He didn't come up with length contraction. That was Lorentz. He didn't come up with time dilation. That was also Henry Poincaré and Lorentz. He didn't come up with anything.
Okay, I get it. You don't like Einstein. That's fine.
What did he patent, though? What's it?
Something to do with a blouse.
Witsit, do you know what he won his Nobel Prize in?
Yeah, it's to do with his pseudoscientific interpretation of the quantum definition of light, based upon the photoelectric effect, and it was actually not even him that did that either. He didn't even do that either. There were 3 other people that did it. It's so goofy. He didn't do anything. I just want to know, what were the cracks in classical mechanics that relativity fixed?
Somebody mentioned one of them, which was the precession of the perihelion of Mercury.
Okay, this is a great example of like the wizardry that goes on, right? So Einstein didn't predict the perihelion of Mercury, right? Like Einstein's theory doesn't predict it. It was discovered like 4 or 5 decades. It was discovered 4 or 5 decades before that. The reason that Newtonian mechanics doesn't account for is it wasn't discovered yet. Because in every situation, when people proposed a dynamic theory for the sky, it was based upon what we saw happen in the sky. So Mercury's perihelion shift wasn't observed yet. So it was observed 4 to 5 decades before relativity. So it tries to integrate that into its explanation, and it still doesn't work mathematically. To this day, it's called Mercury's anomaly.
Actually, what I've seen, I will need to look up the precise citation, but classical mechanics will produce a precession of a certain size, but the precession is not high enough. It doesn't match the observation, whereas GR predicts the precession amount perfectly.
No, it doesn't. It doesn't.
Okay.
Does it? No,
It
it's
does.
closer. It's closer. No, it doesn't. Okay, what's the care metric then?
That's a specific. You're talking about the what's it called? The solution for the so one of his field equations.
Yeah, which is the primary used equation to be applied to the perihelion shift of Mercury. The care metric.
It's one of them.
It's a
The
curve.
primary one.
A rotating curve spacetime.
Okay, so does care metric work to explain the perihelion shift?
To my knowledge, it does.
No, it doesn't.
Okay.
Because it has to invoke characteristics of the sun that doesn't actually exist. So it has to claim it has more charge, and it has to claim that it spins faster than it does. So there is still something wrong with relativity, even on the solar system scale. Even if it worked amazingly on the solar system scale, that doesn't mean anything. If I came up with a theory based on my desk. I have like some books on my desk. I have an iPad on my desk. Here's a speaker. Here's an audio mixer. Here's a laptop. Here's a microphone. Okay, now I came up with a theory that with different variables, I described everything on here, right? I have a little fan blowing on the left, so things occasionally move. I can predict when they'll move, blah, blah, blah. I came up with a theory for my desk. I'm like, hey, bro, look, I got a new theory of the entire universe and all of existence. Check it out. Look at the desk and read my predictions. Look, I predicted everything on the desk. And you're like, yeah, you saw everything on the desk. I mean, that's cool. It works on the desk. Okay, this is awesome. You came up with a new theory about existence. Let's go test it everywhere else. And it doesn't work anywhere else. And then the person's like, bro, your theory sucks. It doesn't work at all. It's off by like 99% over here. It just doesn't work. And then I say, well, look at the desk, bro. But the desk, it works on the desk. That's
Yeah.
retarded.
So
That's not science.
what would probably happen in that case is that the new theory would simplify down so that it actually matches the predictions of your desk. That your desk is what we would call a special case of that larger theory. Very much like how general relativity essentially reduces down to classical mechanics, given things moving slowly through relatively small or relatively slight curves, space-time.
Amen. In 1933, Fritz Zwicky saw that the mass prediction of relativity was off by 99%. And that's he's attributed to the first discovery of quote unquote dark matter, 1933. Okay.
Correct.
99% discrepancy means your theory is wrong. It doesn't mean that you get to run around for a century pretending it's complete and accurate, or no, now we say incomplete. We can't say wrong, so now we say incomplete. So 99% wrong, and then we'll pretend it's still right. We'll make up a name called dark matter, which is just a fancy way of saying we have no idea, but it must have some type of substantive qualities. But specifically, Einstein said there is no substantive qualities outside of space and time. There is no substantive qualities.
Okay.
But there's something here that has to have substantive qualities. So if his theory says this is all there is, space and time, no substantive qualities. There's only ether in the sense that there has to be physical properties within space and time alone. And that is the only way that you could define ether. In fact, space without ether is unthinkable. But that is the only way that you could call it ether. That is the only physical properties. It's attributed to space and time alone. That was his entire theory. That's what saved relativity, or that's what saved the heliocentric model with Michelson-Morley. Now, 1933, we find out, whoa, we need 99% more substantive qualities. Okay, so that's directly contradictory to relativity's prediction. It's directly contradictory. It's not just, oh, it didn't account for it.
No. I am giving him all the rope, but I get to respond to this.
Okay, great.
Good
So
person.
specifically, if there was any type of substantive quality outside of the three-dimensional world, other than space and time's physical properties of space-time curvature, right? If there's any additional substantive qualities, that would cause an impedance within Michelson-Morley, which would show a friend shift. The entire thing he's famous for is removing the substantive qualities of the etheric background that existed at the time, introducing relativistic reference frame. Okay, so then we look out into the sky, taking his prediction of this amount of mass, this amount of gravity, and we see it's off by 99%. So we make up a term called dark matter. That's it. We just made up a term. It's undefined. It in theory has to have substantive qualities. That's why we called it dark matter. Okay, so how can relativity specifically say there is nothing with substantive qualities, and then you invoke a name of something with substantive qualities, and that doesn't contradict relativity?
Okay. I'm sorry. Are you done?
Yeah, oh yeah.
Okay. I've said this twice. I'll say it a third time. Relativity and dark matter, they're not in conflict. Actually, as I've said, what Zwicky didn't use general relativity when it comes to his observations of galaxies in a cluster. He used classical mechanics. The problem is the reason why dark matter is an issue is that the dynamical mass, as seen from the motion of the objects, in this case, gas within a galactic cluster, does not match what we would consider to be the luminous mass of that, which is what we get in that case. I think he was basing it off a visual. So in this case, general relativity has nothing to say about dark matter. They are not the same thing. So Zwicky does not disprove or debunk relativity. What he is saying is that there is matter that is not producing light, but is interacting gravitationally. In terms of substantives, you can look up, and I hate these acronyms, but you can look up WIMPs and machos. There is a camp of the astronomical community that believes that dark matter is in fact baryonic matter, normal baryonic matter, consisting of very, very low asteroids, planets, black holes, really old white dwarfs, things of that nature. Those are called machos, compact halo objects. Now, when you get into WIMPs, or weakly interacting matter particles, that gets a little, I will fully agree, that gets a little bit more speculative in that you have neutrinos as probably the best example of a weakly interactive massive particle, but unfortunately the problem is that neutrinos are too fast. They have too much energy to them. They would be hot dark matter, whereas cosmology tells us dark matter must be cold. And so that's when you start getting into things like axions and non-baryonic particles, and yes, that is all very speculative. It's called.
So is your little magic
mathematical error.
Hold on, Brian. Hold on, Brian. Please, Brian. Please, Brian. Please.
Wait. So is your
having
little
a back and forth. Hold on, Witsit. Witsit's having a back and forth with Dr. Parks. Take a break for 5 minutes, will you, please?
wait? How is your little magical asteroid fairy dust not speculative?
My fairy dust? Okay.
Yeah, your asteroid fairy dust that doesn't interact with light, but it's just baryonic matter, but it's invisible, but I promise it's there, white dwarfs and asteroids. How's that not speculation?
It is speculation in the sense that it is mass that we cannot observe because of our technological limitations. The argument is that dark matter is not some exotic form of matter, but it is in fact baryonic. It is like the matter that we see all around us. It is just that we cannot detect it visually. So therefore, that is the discrepancy between luminous mass and dynamical mass.
Here's the point I'd like to make, right? So obviously what you're bringing up right now is not like the mainstream consensus belief or anything.
It is.
It is.
Well, what do you mean by it? WIMPs and machos are the mainstream consensus.
Okay, well that's pathetic then. So because the mainstream consensus actually is we don't know what dark matter. That's the actual consensus.
Correct.
Is that we don't know what it is.
Correct.
So if I were to respond with that's just fringe, that's just a fringe idea, someone just ad hoc made it up, that's fringe, then no, that's not acceptable critique. But if I bring up someone that says we must unify the fields, here's a unified field theory, we have to update our cosmology, they can be dismissed as fringe. They can be genetic fallacies galore, right? Like Constantine Mice, all I've gotten from his paper is a bunch of genetic fallacies. Right? So it's okay for people to ad hoc speculate, or whatever random person out of any corner makes up a random chaotic theory, as long as it keeps the status quo. And to the point, it doesn't matter if he used classic mechanics or not. The implication of what you just said is if he didn't use classical mechanics, the discrepancy wouldn't exist.
No, that's not what I'm saying.
So then it's a misleading argument.
No. So all right, let me restate this. The issue at hand with dark matter is simply this. When you look at, I'm going to use a spiral galaxy again as an example. When you look at a spiral galaxy, you can look at it in visual light, you can look at it in radio light, UV light, all across the EM spectrum. And from that, you can make an assertion as to how much mass is there based on the amount of the amount of light that you see. And you can also map out the distribution of what that mass. When we do that, that is what's called a luminous mass. But you can also look at those objects in terms of their relative velocity, basically their redshifts. And from that, you can get a dynamical mass. And what we're finding like I said, in the example of a spiral galaxy, and also in ellipticals, but that gets a little bit more involved, is that with spiral galaxies, they rotate as if it is a solid object in a way, where the mass is evenly distributed over the disk. Whereas the luminous observations tell us no, the galaxy is actually centrally compact, that most of the mass is in the center. So there is a mass discrepancy. And so the explanation for that mass discrepancy is very simple, is that and this is how the term dark matter came into existence. It has to be matter which is dark because we can't see it.
I know that. Yeah,
So
like a 5-year-old made up a name. It's literally just a made up name.
So
It doesn't interact with the electromagnetic spectrum, but it has to be material-esque. We'll call it dark matter. How ingenious.
So we now have the problem of dark matter that needs to be explained. And so now you basically, the two major camps are the macho camp that thinks that no, we shouldn't make up new material that we've never seen before anywhere. We should basically say that these are just low luminosity objects. Now, it is not just a claim, a fringe claim or what have you. When you say that, what a macho scientist has to do is they have to say, all right, our assumption of how many white dwarfs there are currently is wrong. So given the physical constraints or physical situation or physical environment of our galaxy, you would actually expect the formation of, hundreds or thousands of times more white dwarfs than we are currently expecting. So every time when you make the assertion that it's a macho, whatever that macho happens to be, you're going to have to explain why there are more than we previously believe there are, and you have to give a physical justification for why that is the case. For WIMPs, if you're on the WIMP side, you basically have to show evidence that such a particle actually exists. If for neutrinos, which currently is the leading particle, if you will, because we've actually observed those. If you think it's neutrinos, then you have to show somewhere through some experimental design that a neutrino can move slowly, that a neutrino can have a small amount of kinetic energy. So these are not just claims. These are ideas which have tests that need to be run. So I reject the idea that you were just simply saying that these are claims that, are not being dismissed for whatever reason, and that say the electric universe is coming up with claims and we're just rejecting them out of hand.
You guys are. Have you read the Constantine Mice paper that I floated around?
I do not. No, I have not.
Okay, I'm pretty sure I sent it to you when you asked for it in the chat. But so,
can you remind me of the context or what's in it?
it's about the electromagnetic nature of gravity, and it shows a mass charge equivalence, and shows that the relationship between Coulomb.
I do apologize. I haven't read it yet. You're right.
Oh, good. But my point is that's just a perfect example of what people do because they don't like it because it's like, oh, this sounds like what people like Witsit say. Now, gravity is actually electromagnetic intrinsically. There must be an equal and opposite reaction. There's reciprocation. You have to invoke a background medium that permeates all space, and that lights nothing more than the excitation of that medium that's already there. And that's what that paper says. And that paper says that the relationship between Coulomb's law and the law of gravitation naturally arises. We show through the mass charge equivalence, and we show that the electromagnetic vacuum and the energy density within perfectly give us all of these values that we currently utilize organically. So that's not okay. That's not okay. So we can hold on to the archaic relativistic nonsense that has been disproven on the cosmological and quantum scale, though. It's been disproven. How could I disprove relativity? That's what I want to know. Because obviously, it making a prediction that's off by 99% doesn't do it. It making a prediction where the acceleration is 10 times faster than it's predicted doesn't do it. It not even being able to be applied at anything on the quantum scale, and none of its predictions working at all whatsoever doesn't do it. Basically, it's unfalsifiable. If something is touted as the status quo belief, and you're not able to challenge it, Nothing can falsify it. How does that not flirt with a cult-like belief? That's what I don't understand. How is religion not a pretty accurate denotation of that?
All right. Well, that's a completely different topic, which I would be happy to have as a man of faith. I would be happy to have that with. But what I will say is, you asked how can it be debunked, and I've kind of already inferred or kind of led to that. What needs to happen is, you're right. I will be fully honest. There are open questions in with our current understanding of cosmology. Our current understanding of cosmology does not completely answer every single question that we have come up with, or basically observation that we've come up with.
96% of them, yeah. 96% of the composition, right? 96%.
I guess that's your favorite number.
Because 96% is the amount that dark matter and dark energy supposedly are. 83% of all matter in the universe is supposedly dark matter.
Okay. Again, I'll say this for the fourth time. Dark matter and general relativity are not in conflict.
Just because you say that doesn't. Just because you say it doesn't make it reality. Did relativity predict dark matter?
No, relativity has nothing to say about dark matter.
Right, because he specifically said that what is here is space and time. He did not say that the vast majority of what is here is something else that has substantive qualities. So that's why your leading theory is about something else that's not beyond the three-dimensional world. It invokes baryonic matter and says it's just not very luminescent. Oh, we just can't seem to see it. Because if you claim that there's something called dark matter that's in the same dimension as time, or it's in the same construct as space and time, that directly contradicts relativity, where he was very clear. He explicitly said it is only space and time. Only space and time have physical properties, and there is no substantive medium. He was very clear. That was his entire point.
So, for someone who really doesn't like Einstein as much as you do, you certainly talk about him quite a bit.
It's a leading
general
leading theory.
relativity is far larger than Einstein. It has been developed for decades at this point. So when I talk about relativity, Einstein doesn't come into play other than as a historical note. I'm talking about general relativity as it is currently understood to this day. And I will say it for a fifth time. Dark matter has nothing to do with general relativity, because what general relativity basically says is talking about the motion of things through space-time, given a certain mass. Now, in this case, what we're talking about is a mass which is determined optically or visually, if you will, and a mass which is determined dynamically through typically classical mechanics. So it doesn't have anything to do with that. But let me get back to your original question of how do we, quote unquote, debunk relativity? The way that we debunk relativity, if you want to refer to it as that, is the relativity is the GR classical mechanics scenario. Is in GR, we're having a lot of these. In order for GR to be truly thrown away, or basically put to the side, another theory has to come into existence that will not only correctly predict or explain all of the previous observations, but it will also answer these open questions. That now, if someone wants to put that forward, and it can be demonstrated through many experiments that is true, then it will be accepted as fact. I don't know who they are, but all I can speak to is the scientific community that I'm a part of.
Henry Poincaré, his theory of the bending and warping of space-time with an etheric model is observationally and experimentally identical to Einstein. Secondly, it's logically fallacious to claim that this theory remains true until someone replaces it or comes up with something better. Falsification is independent of replacement. I don't have to come up with a new theory before yours is no longer true. Now, sure, I understand that you would still utilize the theory until you could come up with something else, whatever. That doesn't mean that it's still true. I asked how we falsify it because every way that you could propose to falsify it has already been done. It doesn't work on the cosmological scale. It doesn't work on the quantum scale. And dark matter is fundamentally in contradiction to Einstein's claim. And now you're just throwing Einstein on the bus and saying relativity's evolved since then. Okay, I want you to give me one paper or one example of the relativistic interpretation that claims that there is a substantive background medium. Because there's not one. It doesn't exist. Relativity specifically says that isn't the case. That's how it explains Michelson-Morley.
Okay. I don't know how I can be clear about the dark matter issue, but what I can say is I can address your point with quantum mechanics. That is, I don't know who you're talking about that thinks that believes that relativity can explain things on the quantum level. No scientist believes that.
I didn't say that.
We are. You said that relativity can't predict things at the quantum level.
Oh yeah, it doesn't apply at all, though, even where there supposedly is mass, which means it should apply.
Correct. So therefore, no scientist says that it does. No scientist says that it can. Actually, that is the biggest crack between both quantum mechanics and relativity. And
That's
that
my
is
point.
why we are currently searching for QED. We're searching for quantum electrodynamics. We're looking for that theory that will encompass both GR and quantum mechanics. In terms of, and I, if you want to say that relativity has been debunked in the context of what you're saying, then I suppose you can go ahead and do so, because you've admitted that if it works, we can still use it. So it works, so we're still using it until someone comes up with a better mousetrap.
Well, it doesn't work. See, this is the problem with what you guys do. You keep it, and I'm not even trying to be derogatory. It's like a religious devotion. I don't know another word. Like, you're so flooded in intellectual bias and philosophical bias that you cling on to it. So what you now do is you build all your future interpretations upon it, which means you're just wasting everyone's time. You're wasting your own time. So intelligent people are wasting their time because they're confining their interpretations of future discoveries within the box of relativity that has already been shown to not work. And the few people that are smart enough to realize and get out ahead of the curve and realize this is clearly not going to work, they're mocked, scoffed, ridiculed, fringe, genetic fallacies, they don't count. Oh, everyone knows they're stupid. So that's the problem. Like even Fred Doyle pointed this out many years ago. It started happening in the 70s. Where if you challenge the status quo, then you're dismissed. And my whole point was that it doesn't work on the quantum scale. I didn't say anyone says that it does. My point is it's ignorant to compartmentalize it as if somehow quantum mechanics, which is experimentally valid, it's real. It's not me looking up in the sky and making up theories about how I think light should interact with something. It's a real experimentally valid field, shows that where there is mass, it does not do what gravity predicts in relativity.
And
It
no
can't
one
be true.
in the scientific community says that it does. And
So it can't
if
be
you
true
wanna
then,
use that, and if you want to use that as a way to say because relativity cannot explain quantum mechanics, then it's debunked. Sure, but then I could go around and turn that around and say quantum mechanics is debunked because quantum mechanics doesn't.
Quantum mechanics would work on the cosmological scale.
I have never seen it. I have never seen it done.
Well, yeah, I know you've never seen it done, but that's not
Okay.
my problem. I even showed you a paper
You
where the guy
said
could
that it
do it.
can be done. You said that it can be done.
Yeah, absolutely.
So can you honestly show me how it has been done?
I gave you a paper that proposes a theory. There are many of them. In fact, if you just have a field that permeates all of space, you immediately fix the problem. If you invoke the vacuum state, the electromagnetic vacuum, you invoke a substantive background, you immediately fix the problem. In fact, it works better than relativity on the cosmological scale. So you might want to ask yourself, why is it not unified? Because if you have a substantive background, it has drastic implications, such as Michelson-Morley has to be re-explained. So when I say it works on the cosmological scale, I don't mean with all the presupposed ideas of current cosmology, like the Earth is flying through space. because that's the standstill. If there's a substantive background, the Earth cannot be moving. If there's a substantive background medium, the Earth cannot be orbiting the sun. It can't be because of Michelson-Morley and subsequent tests, which are thousands of times more precise. So that's why we are in this predicament. That's why people say, oh, we'll keep cosmology over here, we'll keep the local scale over here, and then we'll keep quantum over there. As if that somehow makes sense.
I don't know who they are, but I can tell you that that is not really the case. And you make these, and what I'm going to ask you now is, you claim that the paper that I will read, I do apologize for not reading it. The paper that you've put forward, I'm hearing, because what I have said is that any theory that is going to be put forward that is going to essentially replace relativity, or GR, is going to have to completely explain everything that we have done prior and completely explain everything that is that we're looking at now. If that paper can do that, I would like to know, but I suspect that it can't. My question to you is, because it sounds a little bit like you're saying that paper has come out and that evidence has been presented, and we are simply rejecting it out of hand.
Out of philosophical religious bias, yeah. Yeah, I mean, you haven't even heard of it. You've never even heard of it. Tell me why you haven't heard of it. How about that? Tell me why you haven't heard of someone at the Nuclear Institute, the head of the Nuclear Institute. You've never heard of a paper he released in 2021 that actually solves tons of cosmological and quantum problems. Tell me why no one with credentials has heard of it until I bring it up. Tell me what's up with that.
Of the United States?
What?
The United States Nuclear Institute?
No, it's some other country. So this is like the main thing, right? It seemed like a bit of a tactic there. Like, so are you suggesting that this paper explains everything that relativity does? As if a paper is going to go through every phenomena in the world, right? You would have to be able to look at the paper and tell me what other phenomena relativity explains that couldn't. And I can assure you, you're going to have a hard time doing that, because all it does is sew up some of the problems. But one of the major problems that he doesn't touch on, and I wonder if he's even put together, is if you invoke this field that permeates all of space, and then you then say that there's an equal and opposite reaction of gravity, which is obviously more logically consistent than what it currently is. It's a force, but it's not a force, but can thought of as a force. It doesn't have an equal and opposite reaction because it's not technically a force. It's a pseudo-fictitious force, but we can treat it like a force. So it doesn't have an equal and opposite reaction. Well, no, it would. The question would be where. If it's just space and time bending and warping and that causes gravity, then you can't have an equal and opposite reaction because that would straighten out the curvature unless you have a substantive background medium that reciprocates energy. He is addressing this problem. He's saying, look, it's electromagnetic in nature. It does have an equal and opposite reaction. It has a reciprocation in this field that permeates all of space. Okay, and this is going to help sew up the problems of dark energy, sew up the problems of antimatter. This is going to sew up our problems of antiparticles. It's a similar concept, right? And it's going to help fix some of the major problems we have in cosmology, such as the flatness problem and many other problems that he lists. Okay, and at least he's addressing the problems, and he's been completely. I don't even agree with everything he said. That's not even the point. He's been completely ignored. And every time I bring him up to someone with credentials, they just use a genetic fallacy. They point out that he cites himself. Some of his resources are himself. Yeah, because no one else is even taking any alternative seriously. And he also shows what's wrong with the modified Newtonian dynamic theories that are being proposed. So my point is that there are huge issues, and when we're in this little arena here talking, people pretend that those don't exist. People pretend that relativity is amazing. It's not. It doesn't work. Relativity doesn't work. It's been proven it doesn't work.
You seem to be a lover of absolute. Relativity does work in certain circumstances. As I've already admitted, relativity does have problems, but it is not wholly incomplete. Relativity does work. Classical mechanics does work given some given.
So does Lorentz ether theory. Lorentz ether theory works sometimes. So then that's just as valid? So as long as something works sometimes, then it's valid.
Not exactly what I'm saying. But
Here's what you're saying.
Not really.
What gives it an advantage over Lorentz ether theory then?
I have to say that I am not familiar with Lorentz ether theory.
What about Henry Poincaré's space-time curvature theory within ether, which is where Einstein actually stole his work from?
Okay.
Like they're experimentally identical, other than there being a background.
I will
I'm just
take
saying,
your-
like that's
I
you
will take
understand
your
that's not. I guess the point I'm trying to make. I'm not trying to put you on the spot. Like, have you ever heard of this random theory from the 1900s? What I'm saying is like you understand why that's not that's not like a valuable like line of logic. Like, oh, it works some places. Okay, I could give you 1,000 theories that work some places.
some places or in very niche small places.
Will like the ones I just invoked will work in all the places relativity does and some.
All right, so I'm going to address the paper that you've mentioned before. Can you send it? I can't even remember.
I'll send it again.
Send it. What you refer to it by a particular title. I can't remember what it is.
You want the title of the paper? Is that what you're saying?
No, you kept calling it something. It's sort of the C, maybe.
His name is like Konstantin Mice.
Mice.
Works
That's
at the
it.
National Institute for Nuclear Science and Technology.
Mice. It was the mice part that I was like, what are we talking about? Biology? But
The
so
electromagnetic nature of gravitation and matter, antimatter, anti-gravity. Surmise on quantum vacuum gravitation and cosmology. 2022.
all right. So
Drop it in the thing again. But
he's
this is my point.
Nice.
That's my point.
So with this, what I'm saying is, all right. So this has only been around for 2 years. Scientifically speaking, that's really not very long. If this theory can explain things, and he claims that it can explain other things, well, give us a bit of time, dude. I mean, it's only been 2 years. There's a lot of ground to cover. I mean, if this can do it, and there are tests that can be performed, then just wait. We'll perform them, or the scientific community will perform them, and then if what you are saying is true, what Dr. Mice is saying is true, then we will adopt this new theory.
Well, you say that. But what he fails to elucidate, and I know for sure, is that his theory has drastic implications and it will change all of cosmology. For one, it's going, and he acknowledges this part, but it will fundamentally change mass, the definition of mass.
Great.
He proposes a mass charge equivalence. Now, anyone that knows anything about mass in its current state, we don't know what it is. Describe effects of it. That's it. No one even defines what it is. Oh, it's resistance to acceleration. That's not what mass is. What is it? No one knows. This guy proposes a theory, but if you invoke what he said in the very beginning, he points out right here, it says, it corresponds to, let me just read the first 2 sentences. We show that the electromagnetic quantum vacuum derives directly from Maxwell's theory and plays a primary role in quantum electrodynamics, particle physics, gravitation, and cosmology. It corresponds to the electromagnetic field ground state at 0 frequency, a 0 energy cosmic field permeating all of space, and it is composed of real states, and he calls them keenons.
Yeah.
Kevo equals vacuum. Okay, now there is no way to build upon that fundamental idea without invoking substantive quality. Okay,
So
now that's
does
a
he talk
you
about a
problem. That's not a me problem.
substantive quality in this paper.
He's not going to use the word substantive. That's actually my point. It seems like he knows what he's going up against, right? And he's like, okay, we'll propose a few paradigm shattering things at a time. And I haven't talked to the guy. I don't know if he's put this together. I don't know if he's going to try to propose a theory where he doesn't have substantive quality. I can tell you that it's not going to work if he doesn't. And he says photons are local oscillations of keenons guided by a non-local vector potential wave function with quantized amplitude. They propagate at the speed imposed by the vacuum electric permittivity and magnetic permeability, which are intrinsic properties of the electromagnetic quantum vacuum. Dude, this is literally what I've been saying. I'm just some dude. I don't even have a degree, dude. I dropped out of college. So the question is, why am I able to see the same thing that this guy is able to see, but so many people with degrees in the field aren't able to see it? It's because it goes against the status quo.
You are saying so. So you were saying that there is a substantive field.
Yeah, there's a substantive background, absolutely.
Okay. And so you are saying that. Have there been, and you've already admitted that he has not been able to explain all the things that relativity has explained.
No, I didn't say that.
I believe you did, actually.
Well, I'm saying one paper could never possibly, the paper is proposing the theory.
Yes.
As if the paper's supposed to say, here's everything that relativity currently is applied to, and here's a replacement interpretation for all of it.
So you're willing to go with a theory that has not really been tested and say that that's a good idea, whereas relativity, which has been tested and verified many, many times, there are open questions, but has been verified many, many times, you're willing to out completely.
What? No, no. This theory actually is built upon quantum evidence. Relativity can't even step in the door.
But it is a theory that has not been fully tested. It has fundamental, or like physical underpinnings that have been verified, I'm assuming, but it has not been able to, or has not yet been able to explain anything that, or much, I guess, hate using subjective terms, but it hasn't been able to explain the things that relativity has explained and gotten right.
You'd have to
I don't
name
understand
something
why
that.
you're just completely abject rejecting entirely and going to a paper that hasn't, or going to an idea that hasn't been fully tested.
See, this is another tactic that happened. So when I say relativity is wrong, people want to try and pretend that everything relativity acknowledges is exclusive to relativity. As if I deny relativity, I must deny everything it addresses. That's ridiculous. Einstein didn't even make relativity. Everything is from someone else.
Don't know
So
why you're bringing him up.
the fact that there's a bending and warping, why would I have to get rid of that? It makes more sense in a substantive background, which Einstein himself spoke about. And you say it doesn't matter what Einstein said. It does. If the theory hasn't changed since he said it, then it does matter. It's still the theory. And he specifically says that space, he said, of course, ether exists. In fact, space without ether is unthinkable. I say this because ether simply means that space must be endowed with physical property. And if we do not have physical properties, then we have nothing which to measure with clocks and measuring rods against. Okay, so he's saying that there has to be physical property. Obviously, physical properties make more sense in a substantive medium than in a conceptual one. So, like the bending and warping, that's my theory. That makes more sense in my theory. That's my effect. That's not relativity's effect. He stole that. That's my effect. That's ether's effect.
I see.
You see what I'm saying? So you see, can we meet there where it's like, this tactic of like, if relativity makes a prediction and you're saying relativity is wrong, then everything relativity talks about, you can't use it. That isn't true.
That is not what I'm saying. And
You
actually, I
agree with
kind
me?
of said quite the opposite, because I said that classical mechanics can still be used, even though relativity, from a fundamental point of view, is not reconcilable with classical mechanics.
So off the
It
top of your head, can
depends
you
on-
name one thing that relativity predicts or is applied to that like a substantive background medium wouldn't work for?
I could not give that to you because I have not worked with a substantive background medium, because that is not the current science. I can tell you that I've worked with relativity to a certain extent, and it has matched predictions.
Yeah.
So, or it's useful.
I
So
agree it's useful, man, because it was built upon observation. Henry Poincaré is the real genius that came up with it. So I don't disagree that it's useful.
why is Poincaré, or I can't speak French. Poincaré, why do you think Einstein is now the hero and Poincaré is basically a footnote?
Because he refused to get rid of the ether. He said that not having an ether is impossible.
And why was he rejected? Because he wouldn't get rid of the.
Because Michelson Morley put everything down to the point where either you had to get rid of a substantive ether or the Earth had to stop orbiting the sun. So obviously,
So
was chosen.
Nicholson Morley is essentially saying that either the ether or the sun isn't moving through space. So
yeah, pretty much.
So the scientific community basically took that as saying, well, we know that the space, so therefore there has to be no ether.
Yeah, that's called a religion. It's a philosophy.
I got a question.
Stellar parallax can in fact demonstrate that there is motion, that the Earth moves around the sun.
No.
Stellar redshifts also can do it. I know you're going to say no,
That's
I don't
insane
know
to
how
me that
you
you
can
think
say
that's
no
legit,
because
dude. I don't.
I have colleagues. Actually, Recons is a group at my former alma mater whose job it is. Who they have successfully mapped out every star within 25 parsecs, and they've done it exclusively using stellar parallax.
That's what's
So,
up. So you're saying if I gave you $1 million, you couldn't explain the phenomena called that's referred to as parallax on a stationary Earth?
if you gave me $1 million to do it, I'd certainly try.
And you don't
I
think
don't-
you could do it?
Probably not. No.
Okay, well, I
Well,
just
I don't see how the $1 million has anything to do with this.
the stars are just moving, man. Like I don't know why that's so confusing. The stars have their own type of movement.
They do. It's called proper motion. But on top of that, they also have parallax.
Why is it not possible that they have different types of motion within their overall motion?
I didn't say there was. I said the star has both proper, well, actually, the star has proper motion. On top of that is described through either radial motion and translational.
If
You
the
can
stars
guess.
are moving around a stationary Earth, why can't they have individual movements as well?
So is it just me, or am I saying that they have individual movements? Stars have individual movements in and upon themselves, regardless of the Earth.
So on a stationary Earth, why can't the stars just have individual movement that you're attributing to parallax by presupposing your philosophical bias?
So why is it that that motion for all of these stars is basically matches up with the idea of it's back and forth motion? What is causing it?
It moves in a toroid.
Actually,
Moves in a
it
gigantic,
moves in an ellipsoid, actually, but yeah.
in a giant toroid. You can map them out from a central position. It's all a toroid. So anyway, man, parallax is
No, 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 not anyway. You're just throwing out a toroidal that I'm like, what exactly you're talking about? How do you explain if it's not the Earth moving through space? How do you explain stellar parallax?
the stars themselves are moving.
What is causing that motion?
Well, that's a good question. I have a theory that you're going to all of a sudden expect definitive experimental evidence for, but then we can talk about magic asteroid dust. So, yeah, like
Because
there's a central energy source that's radiating out down through the ether that presses down. This causes a vortex. The entire motion of the sky is wrapped up inside of this toroid that has a vortex, just like all physics shows us with everything in existence. And we have different conjugate movements or geometries within a toroid. This has a cycle. The stars have a cycle within this toroid through this vortex, and they have individual movements based on where they are in the vortex and what point in time it is that we observe them within that movement inside the vortex, which
why
has
do they have the
centrifugal
individual movement?
divergence, centripetal convergence, it's breathing in and out effectively. It has vortices and anti-vortices, right? And this is on the small scale it's observed as well. And of course, that means my theory is better than yours because mine can unify the small and the big scale.
This isn't a competition.
Well,
So what I'm saying is, can you be more specific as to what is actually you say breathing in and out and all that kind of good stuff. Can you be more specific as to what is causing the unique specific phenomenon of stellar parallax?
yeah, I just did. The stars themselves are just moving within a giant cycle inside of a toroid. You guys just saying it's called parallax doesn't mean anything.
Why is it moving inside? Why is it moving independently within given ellipsoids, given observed ellipsoids within that toroidal field or what have you?
Why is it moving within an ellipsoid inside the toroid?
Yeah.
Because you can just map out that's the different field lines inside of a toroid. They're ellipses.
Why are the toroidal field? Why do those field lines? So you're saying that inside that field there are basically toroidal fields that cause a test particle to move in an ellipsoid. Why?
That's the field lines inside the toroid. It's not that there are a bunch of different toroids causing anything. The overall toroid has ellipses in it. We know this is how ellipses work. We can even look at a magnet under a ferrocell.
So why is it that the ellipsoids are there in the field? What about the field causes the ellipsoids?
So now you're just asking about the fundamental manifestation of a toroid in the first place, which I think I do know the answer to that, and mainstream particle physics can't explain it, but it's because there's an ether, and a toroid is nothing more than the conjugate meaning, of course, the reciprocated or inverted, the other side of the coin, right? So you have conjugate geometry. You have the hyperboloid and you have the toroid. You have the centrifugal divergence, and then you have the centripetal convergence. You have the vortex and the antivortex, breathing in and out. Okay, this is, of course, seemingly the dielectric and the magnetic and their conjugate geometries intertwined, and it's just a process of trying to get back to the ether, which is a pure potential state. It's pure equilibrium, and that's all it is. If you look at the center of the magnetic field, that is basically concentrated ether. It's inertia. It's pure equilibrium, which is everything in existence is just trying to get back to that state, just like we see everywhere else. This causes what we call a toroidal magnetic field. That process of trying to get back to equilibrium and pressure mediating relative to this pursuit causes this to happen. And then within this pursuit and this vortex, depending on the distance away from the center, you're going to have a certain ellipsoid around it trying to get back to the center. We see this with magnetic fields.
So sorry, I missed that last sentence. Can you repeat that last part?
Basically, whatever it is that is a certain distance from the center is going to be trying to get its way back to that center to get to inertial state. So it's basically going to take its route relative to the distance of that vortex, which results in an ellipse.
So the ellipsoidal motion is due to basically attempting to get back to an equilibrium state. Is what I'm hearing.
In the center where the vortex is. Yeah.
Okay. Again, I'm going to ask why, but actually, really, what I want to ask is that dude who is currently in the chat, or at least in the voice chat, he has been asking for a textbook for flat Earth because in order to convince us that we're wrong, you need to have a textbook which lays out positive claims, positive evidence. And he wants to know if there's anyone in the community who can provide the mathematical underpinnings that this theory is going to require. And I was wondering, are you confident with the math? Can you do that?
An entire textbook, a flat Earth or a textbook about the entirety of flat Earth.
Well, you're putting forward this idea about this ellipsoid that is being caused because a particle is moving down to trying to get back to some kind of equilibrium position
based on actual physics. And
yeah, so that actual physics can be described using mathematics. And I'm wondering, can you do it? And if you can't, do you know of anyone who can?
So it's very tricky actually to quantify this phenomena because you cannot quantify the immaterial. So you could try to, that's not something I've ever been particularly interested in because I know it would require quantifying the immaterial. You cannot do that. You can come up with the best construct you can to quantify things. That's what quantum mechanics is. So in theory, you could, if you mean like quantifying, say, like celestial observations, sure, you could come up with a quantification for celestial observations within a toroid. When it comes to like mathematically mapping out the entirety of a magnetic field, I mean, yeah, you could. We do it right now with a construct called virtual photons. But what is that? So it requires you trying to quantify the background, which is technically immaterial. Right. So that's personally, I think that's one of the main problems we have. So no, I've never been interested in trying to add to that problem. But like, yeah, in theory, you could, like,
you don't think that that's necessary?
I don't think that math is reality. I don't think you can quantify the immaterial. I think it's I would yield and say necessary to an extent. Yeah. I think that quantification is very important. It helps us replicate things and get more precise with future and subsequent observations. I don't hate math, but I don't think that it's reality. I think it's very limiting. And if people try to conflate their mathematical construct to what reality itself is, it's very detrimental. This is why we have something called virtual photons, to explain magnetism, and that's ridiculous. That's made up pseudoscience. Right?
Well, with science, typically the way it's done is that you have a mathematical description of whatever it is you're looking at, the universe, what have you. And then you can use that to make predictions. Such for example, I predict what these two binary stars are going to be in a certain orientation given a certain amount of time based on the orbital dynamics that I've calculated or that I surmise. So wouldn't you want for this model, for the electric universe model, that's what I call it. If you don't like that term, please correct me. But with the electric universe model, would you not want that to be fully quantifiable using mathematics like relativity is, like quantum mechanics is?
Relativity doesn't fully quantify the universe. Like, yeah, sure, I would be in support of there being a mathematical construct, but I would be I think it would, be very important that people specify this is just the best that we can come up with. Just like the math for relativity can explain singularities or black holes or many other things. So,
It's interesting that sorry.
you can only do so much with math. That's my point. And like if you think math is reality, that's the problem. And in fact, this is you brought up a perfect example. Orbital mechanics within your paradigm is a perfect example. You came up with some math for orbital mechanics, but you make claims of anomalous physics where you just regard the inertial force, you just disregard it entirely. Regard the centrifugal force in the orbital mechanics, you don't even account for it. Just regard the inertial force and then use the word reference frame. Well, you made the math work, sort of. If you do two bodies at a time.
We can very easily predict where the future position of certain bodies are going to be using orbital dynamics. So I don't know how that's wrong. If I tell you that there's going to be a transit eclipse of that star's light is going to drop in 15 minutes, and that light, that prediction is based on orbital, and then that light drops in 15 minutes. I'm not entirely certain how it's wrong.
Well, what if there's 3 moons and the 3-body problem comes into play? It's just confusing.
Like, it's not that it's wrong. Like,
No. That's a separate issue entirely. How is it that given he's saying that orbital mechanics does not incorporate all of these other things that are physically happening?
Yeah.
But what I'm telling you is that orbital mechanics, as it is described now, will tell me in a certain position that or a certain time that this star is going to get it eclipsed in 15 minutes, and then we see in 15 minutes that eclipse occurs.
You're making my point stronger, though.
Why is that wrong?
You're making my point stronger. If you see an observation and then you apply a mathematical construct to it, and then you're able to use this math based on the cyclical nature of the observations and relationships between multiple things in this scenario, and then you think that somehow proves the conceptual backing behind the math, then you get lost in pseudoscience. So that's what you're doing here. I'm talking about the conceptual interpretation of orbital mechanics being wrong fundamentally, doesn't account for a law of physics that we know exists. A real life thing in physics that we know exists is ignored in the current understanding of orbital mechanics, but then someone responds with, but the math works. Like if we go back to where it came from, which is Kepler, he said that basically the Earth is inside of a giant orchestra, and that everything is based on auditory vibration, and basically what we call stars are just musical notes, and they all move around based on this beautiful, majestic, celestial song, and everything is vibrational in nature within a fluid medium.
Sorry.
Well, I'm just saying, you see how you can still use Kepler's math and have a completely different concept. That's my point. The danger with math is people think that math is reality for some reason, and then whatever the quote-unquote popular or agreed upon concept at the moment is, as long as they tie that to the math, people say, oh, look, this concept's true because the math works, which is ignorant.
So you have a difference between Kepler is actually a great example. With Kepler, you have an example of empirical. This is when you observe a phenomenon in the real world, and you see that it that goes through cycles, and you are able to map those cycles using mathematical relationships. But then you have fundamental law like gravity, like Newtonian classical mechanics, which starts from a simple premise that gravity exists. It is the constant, or it is defined, or it is described as a constant times the mass between two, or the masses of two objects separated by a distance squared, and then you can use that to actually independently derive Kepler's laws. And in fact, when he did so, he actually generalized Kepler's only be used for those things in the solar system. Now Kepler's law, the Newton's revision, can actually be used to describe the orbital dynamics of any really.
Well, look,
we'll say
Sort of.
I don't want to derail your conversation with Witsit. It sounds like a good one. I just got here, but when it comes to like Newtonian laws dealing with gravity, like that was replaced by Einstein, right?
Yeah, we're kind of
Like-
doing a one-on-one, Lou, by the way.
Oh, okay, gotcha.
Yeah, just put yourself in.
I don't want to monopolize. This,
Yeah.
guys.
Yeah, that's cool. Let me respond to what you just said. So, like, dude, you're making my point again, okay? Which is that Newton came up with, he's the first, okay, for those who don't know, of course, Kepler proposed the kinematic relationship, okay? And Newton's the first one to come along and propose a dynamic relationship built upon the kinematic relationship that Kepler observed and denoted the cyclical nature and then denoted a kinematic relationship, a geometric one. Then Newton comes along later and proposes a dynamic mathematical model to build upon it. Okay? Newton specifically states that he has no idea what gravity is.
Correct.
That to think that it would work without some type of medium is absolutely absurd. That he couldn't even imagine such a thing unless it was a direct act of God. And then went on to propose an ether that was fluid, incredibly dense, but had no impedance. But now what people have done have taken his math and pretended that he had some revolutionary concept of gravity. No, he didn't. So math is cool and all. It's very useful, but it cannot be conflated to the validity of the concept that it's tied to. That's my point.
And I don't know who they are that says that he came up with a wonderful theory of gravity. Yes, Newton freely admits in his Principia that he does not understand the underlying mechanism by why gravity works, but he acknowledges that his description of gravity is accurate. It is the best description of gravity that there is. Him, like many of his colleagues today, were not comfortable with this idea of action at a distance. For them, action has to have some physical mechanism via which to transmit some kind of force from point A to point B. They basically were looking at gravitational effects as if a magical force was moving things, which was, anathema to them. But we now know that that action at a distance can work because you have things like quantum dynamics or quantum mechanics, where at least with electrostatics or electrodynamics, the carrier particle for that force. Sorry, let me back up. The electrostatic force, the carrier particle for that force, is a photon. Yeah. So, in essence, you have something physical manifesting from point A, going to point B, and causing the force. Now, if the graviton is real, then relativity certainly is not the function, but so far the graviton has not been found. Okay. So, again, I kind of just to wrap it all up, just for dude's sake, am I correct in saying that you're fine with a theory of the universe or the theory of science that is in some ways quantifiable, but in other ways shouldn't be or can't be?
I missed the last question, sorry.
So, are you okay with a universe being quantifiable at some level, but at other levels not being quantified and possibly not, and possibly even not, you shouldn't quantify it?
No, I don't think there's anything intrinsically wrong with quantification. I think that it would be needed for progress. I think, again, the problem is conflating the mathematical construct with reality. And this is oftentimes done. And I'm going to yield the floor here because it's my birthday, and I guess Kai wants to have a glass of rosé. But I'm just going to say that I have, I'm like trying to run like 5 businesses, and I have 2 different YouTubes I have to run, and I have a new website, NASA audits with 150 resumes that I'm behind on, and all this stuff. And I run into people all the time. They're like, Austin, why don't you replace all of physics? And it's kind of insane. But I do plan on writing a paper specifically about gravity and what it really is, and then discreetly giving it to someone else so that they can publish it. But there is no way that I can by myself remap the entire world. And
I
it's
don't think
insane.
anyone's asking you to.
Well, sort of.
I think with like I said, going back to Dude, I think what he wants or they want is just someone to do it. And when I say someone, I think really you're going to need the scientific community currently. You're going to need a lot of people. You're going to definitely need more. I don't think anyone expects that a single person is going to come up with the entire mathematical framework of a flat Earth model. But what I haven't seen, and a lot of, shall we say, debunkers haven't seen and want, is for someone to try, for someone to actually come up with some kind of quantification of a flat Earth model that can provide a positive claim.
Of what though? Like there's no such thing as a flat Earth model, just like there's no such thing as a globe Earth model. You model different phenomena. There isn't a globe Earth model. There's a geodynamo model for the core. There's a geomagnetic model for the magnetic field. You have different models for different phenomena. Like as to astronomical predictions, I think that's very attainable. One of the major problems that I don't know why good faith would dictate that people acknowledge this, but it is never acknowledged. Flat earthers openly admit we do not know what's past the 60th south latitude. In fact, this is a huge distinction between us and globers. They seem to think they know for sure what is beyond there when they objectively do not. So not knowing the exact central point or the outer regions is a huge hindrance to any type of mathematical specificity. As it pertains to a toroid and how our observations of the sky can be mapped on a plane, yeah, you can absolutely do that. If you wanted to do the magnetic field, you could absolutely do that. There are many things you could do, but it's a lot. Basically, you have to rewrite all of physics or go back to the 1900s and then rebuild upon that. So yeah, that's pretty much my conclusion is I know, and I know it's going to sound like arrogant, but I know for a fact that the only progress that can be made will require acknowledging a substantive background medium, formerly known as the ether. It will require unifying dark energy and gravity. It will require acknowledging a reciprocation in this background medium, and a substantive quality will then basically make the Earth stationary. And we will not unify any of these fields without acknowledging that it's all electromagnetic in nature. And that's pretty much it. There's no way that a couple of us can replace all of it when we have millions of people diligently trying to avoid it. So I would love for people like yourself or quantum physicists and stuff like that to help do it and stop ignoring the inevitable and then touting the archaic, outdated, effectively belief systems. But that's up to you, man. So
The scientific community is looking into various different alternatives to relativity. That is, we're not just taking relativity on faith. We're not just basically clinging onto it for life. There are people out there. As to whether or not people are going to follow Konstantin Mice's example, I have no idea. The community is huge, and just as you are saying, you cannot be expected to derive the mathematical framework for the Earth. I cannot be expected to know every single new paper that has been coming out on the subject.
I know. I'm leaving my judgment about that until you read it. But I just want you to know I don't have a good track record with it, and not because there's something specifically wrong with it. It's because it challenges the status quo, and I've given it to quite a few people with credentials as quote-unquote hostile witnesses, and they all just say, he just does what you do, but with math. He's just making baseless claims. But we can make up fairy tale claims about dust and dark energy and dark matter and whatever else. So, like, I would just suggest you reading it, like, with an open mind. And I think you're one of the few people I feel I can have pretty good faith interaction with, and that's why I agreed to have you on my channel. Although I know that was a long time ago, but yeah, if you look at it, I'm happy to hear what any of your honest critique is. And I would hopefully, in conclusion, you can like acknowledge that he is at the least addressing major problems that are somewhat being ignored. You know, and I know you're not going to like that, but they are kind of being ignored.
I all right. I don't have judgment on whether it's being, but I hear you, and I will, and I promise you, I will read it, and I will get back to you as soon as I am done with it. I'll probably have to DM you about it.
Yeah, that's cool.
But I know you want to go. I will just throw this out there for shits and giggles. One of my former colleagues who is no longer with us, Arlo Landau, he actually was stationed at the South Pole in the middle of Antarctica back in the 50s. He did a wonderful. He would give a yearly presentation on his experiences down there. Pretty awesome. So I personally, like I said, unfortunately he's passed away, but I have personally met someone who has claimed to have been at the South Pole, and he has no government affiliations, or didn't have any government affiliations. So
The South Pole's in the middle of a continent that's like impossible to get to without dying, but okay.
You went to the magnetic South Pole or the ceremonial?
I think it was the geographic. I think it was the greater geographic.
Wow, this dude's freaking Bear Grylls. This dude's astronomical Bear Grylls. But anyway, I'm sure he did go to Antarctica, right? I don't dispute that. All right, cool. Yeah, nice talking to you. Like, I'll stay in here, but I'm not just gonna like have this like one-on-one thing. I'm gonna kind of chill.
Dude, it's your birthday. Go get drunk, stoned, whatever.
Yeah. I don't do those things, but yeah, cool. All right, nice talking to you, man.
Happy birthday, Witsit.
Birthday, Whit.
Oh